Hi guys, today we're going to be going over some of the more difficult questions on the two worksheets that you guys had for classwork. Both of these are testing your knowledge of relative humidity and dew point. Two topics which at this point you should have watched three different videos about. You should have an idea of what we're talking about. A couple reminders. Humidity is the general term that measures the amount of moisture or water vapor in the air. That's water as a gas. That relative humidity is referring to the percent of the air that is filled with water vapor, H2O, as a gas. That saturated means that we have 100% full air. It's filled, it can't fit any more water in it, and that's when we're going to get condensation or water turning into droplets coming from a gas, from water vapor to little droplets, often on like a mirror, or a can of Coke, a cold can of soda, or high in the atmosphere in a cloud. Okay, so with this stuff in mind, we have to imagine we're swinging around a sling psychrometer, which is the tool that is used in order to do this. As we swing it around, we're going to get two values. We're going to get one value from a dry bulb thermometer. That's a thermometer that has nothing on it, regular old thermometer, plain thermometer. And then the other side will have a wet bulb. And the wet bulb, we get evaporation off of this wet bulb. And that evaporation causes cooling. Brings the temperature down. So it's the same reason that if you come out of the ocean on a nice warm summer's day, the breeze comes in and you feel cool. The breeze itself is not actually cold. The air in the wind that is touching your skin and causing you to feel cool is not itself cold. It's that it's causing the water that's on your skin to evaporate. And in order to evaporate, that water requires energy. It's what we refer to as an endothermic reaction. It absorbs energy or heat energy. And it does that and it takes it from your skin. So we feel cooling from evaporation. So when we swing this wet bulb thermometer around and we get that cooling on that wet bulb, it brings the temperature down. Now, how much it goes down is all about how dry the air is. The air is really, really dry. It has a low percentage relative humidity. Then it's going to go down a lot, right? It's going to be way, way less than the dry bulb of this psychrometer. If it's pretty humid, it's not going to go down so much. So you're going to swing it around. Dry bulb sort of stays the same. And then the wet bulb comes down maybe a couple of degrees. So the difference between them, this wet bulb depression number that we're going to be dealing with here, isn't going to be very much. So that's an indicator it's a pretty humid day. Lots of water vapor in the air, maybe high chance of rain, something like that. And finally, if you swing it around and there's no evaporation at all, that means there's no more space in the air to fit this water vapor, and therefore we have 100% humidity, saturated air, high likelihood of rain, and of course the important word to remember today, which is condensation. Okay, let's do a couple of these problems now that we've established some important facts. We're going to start with something on the easier side, and we're going to do some harder stuff afterwards. All right, so here we go. Let's do this one. Number 4, 6 is the dry bulb, 5 is the wet bulb. So we're just going to subtract to get the depression. So 6 minus 5, we should have a 1 here. So we're now going to use the dry bulb, 6, and the wet bulb, 1, in order to get our humidity and dew point on our reference table. So let's get the reference table going. We're going to be here. Let's get dew point first. We have 6 and 1, right? 6 for the dry bulb, that's here. 1 for the difference. I'm going to see where they meet up. That's the number 4. So that means the dew point is 4. So I would put a number 4 right here. And then we're going to do the same thing with the relative humidity chart using that 6 and that 1. 6, 1, right? This first column's for 0. This column's for 1, as you can see up here. So 6 and 1, that's 86%. Notice what we said. The difference was going to be low. The difference between the dry bulb and the wet bulb was low. It was only 1. So we knew it would be a high humidity, hence 86. And we also, as we said before we started, is that if we only had a difference of 0, if they weren't different at all, the wet bulb temperature didn't drop, there was no evaporation off the wet bulb, we knew the air was filled with water, no evaporation could occur, so 6 and 0 would be 100%. In fact, any dry bulb and the wet bulb being the same value are going to give you 100% humidity. Another thing to note about that situation is that that also means we have air temperature equals dew point. What's dew point? Dew is that stuff that in the early morning you walk on the grass and you scuff up your sneakers, right? They're wet. Why is that? Well, at night, the air temperature drops. It drops until it hits dew point, and when it hits dew point, then we get our 100% humidity condensation situation all over again, and there's your droplets. Let's try to knock out a few more questions. Let's do a harder one. So over here we did 17. 26 was the dry bulb, and 15 was the dew point. So how do we do this? Okay, so 26 and 15. So 26 was, this is the dew point chart, 26 was here, and 15's the dew point. So it's not this number, because this is the difference between them, the dry and wet bulbs. We want to find the number 15 in here, because that's the dew point. So boom, so we've got 26, 15's the dew point, and now we can figure out what the difference is. Well, the difference is 7. Okay, let's go back to the chart. The difference is 7. So that means that this minus 7, right? 7 was the depression, so we can put 7 right here. We can do 6 minus the 7, and that'll give us 19. So we should have a 19 right here. The wet bulb would have been 19. So 26, 19, 7, and now we're going to use that 26 and 7 to get the humidity. Nice and easy. 26 and 7 under humidity. 26 and 7. So 0, 1, 2, 3, 4, 5, 6, 7. That's 51. 51 what? 51%. Okay, let's knock out a couple more. I want to pick a particular tough one that causes people trouble. Okay, anything that's an odd number causes people trouble. Let's do that. 11 and 6 on this chart. So we're going to do 11 and 6 for each. So we do 11 minus 6. 11 minus 6 is 5. So we have a difference of 5. So we're going to use the 11 and the 5. But we're going to scroll down here and find that there is no 11. But there is a 10 and a 12. And we said there's a difference of 5. So we're going to go down here and we're looking at these two numbers. So here's what you do with this situation. Anytime you get a situation where you're using an odd number, you're going to go to the two even numbers that surround it. So if we're using 11, we're using 10 and 12. So we're going to, ready? Take the average of these two numbers. How do we take an average? We add them and divide them by 2. Why 2? Because there's 2 of them. If we were averaging 3 numbers, we would add them and divide by 3. Right? If we're averaging 5 numbers, and so on and so forth. So 1 plus -2 gives us -1. -1 divided by 2 is -0.5. Okay, we can do that on paper, we can do it in a calculator, but I'm just going to put it out here that we should have a -0.5 right here for this one, for dew point. And then we can do the same thing for humidity for 11 and 5 and try it. Maybe it'll be easier numbers this time. We'll use the 10 and 12. We have 5, so that's this column. So 43, yeah, this should be easier. So 43 and 48. So I'm going to go 43 plus 48 gives me 91. And then 91 divided by 2 gives me 45 and a half. That's 45 and a half for humidity. I'm going to jump ahead to here and see if there's anything we can answer that would maybe be a tougher question for you guys. And then if you guys have any more questions, just shoot me an email. I'm going to do the word problem. Which statement best explains why an increase in the humidity generally means an increase in chance of precipitation? Okay, the dew point is farther from the condensation point. First of all, it's the dew point, but no, that's the opposite. That means it would be drier. The amount of moisture in the air is greater, making the air heavier. It seems kind of true. C, the specific heat. No, we haven't even done that yet. D, the air temperature is closer to dew point, making cloud form. This sounds the best. The air temperature is closer to dew point, because the closer it is to dew point, the more likely we get condensation. The answer is D. All right, guys, if you have any other questions about any other stuff related to this, please shoot me an email, and I hope you guys have a great day. Take care.